Good afternoon, all. Am I audible? Hello. This is week 3 Microelectronics Device to Circuit Problem Solving Session. I am Arpita Biswas, a PhD scholar from IT Jodhpur in Electrical Engineering Department. So this is the last session of this class. So let's start the session. So this is more details about me. So here we are going to discuss about some of the MCQ and some of the numerical. So if you have any doubt, you can ask, and also please unmute yourself and try to give the right answer. So this is the and please there is no hurry. You take your time and then try to give the right answer. This is the question number one. Combinational logic circuit are the functions of dash. So this is the options. So kindly go through this options and try to give the right answer. So what is the right answer? The right answer is the current input value. Okay, so option B is the right answer. Next, move towards the question number 2. Setup time in digital circuit is first option the time required for a signal to become the stable after the clock age. Option B, the time interval during which the input data must be stable before the clock ages. Option C, the time required for a flip flop to change its output after the clock ages. And option D, the time interval during which the input data must be stable after the clock ages. So please go through the question carefully and try to give the right answer. So what is the right answer? Question number two, the right answer is option B. The time interval during which the input data must be stable before the clock ages. Okay. So next move toward the question number three. The hold time in digital circuit is the time required for a signal to become the stable after the clock ages. Option B, the time interval during which the input data must be stable before the clock ages. And option C, the time required for a flip-flop a change to change its output after the clock age. And option D is the time intervals during which the input data must be stable after the clock age. So please go through the question carefully and try to give the right answer. So what is the right answer? So the right answer is option D. The time intervals during which the input data must be stable after the clock age. Okay. So next move toward the question number four. Clock feed through is basically a capacitive coupling between the clock input of the pre-charge device and the dash. First option is the power supply. Then second option is the dynamic output node. Option C is the ground terminal, and option D is the data input. So try to find out it. So try to find out the right answer. So the right option is option B, the dynamic output node. So next move toward the question number 5. Clock jitter refers to. First option is the spatial variation in arrival clock transition. Option B is the temporal variations of clock at a given point, and option C is the potential variation of the clock, and option D is the none. So please go through the question carefully and try to find out the right answer. So what is the right answer? Question number 5, the right answer is option B. Okay, temporal variation of a clock at a given point. So next move toward the question number 6. Skew will always try to dash the frequency, while jitter will always try to dash frequency. First option is the improve. Second option is the improve reduce. Third option is reduce improve, and option D is reduce reduce. So try to find out the right option. Yes, what is the right answer?
Skew will always try to improve the frequency, and jitter is always to reduce the frequency.
Yes, option B is the right option. Good. Next, move toward the question number 7. Mismatch in interconnect and power supply variation are major sources of dash. First option is skew and jitter. Second option is data loss. Third option is the metastability, and option D is the data flip. So please try to find out the right option.
Ma'am, I think metastability.
No, question number 7. The right answer is skew and jitter. You can cross check it. Okay. The right answer is option A. This is the question number 8. So consider the D latch shown in the figure, which is the transparent when the clock input is high and has zero propagation delay. In the figure, the clock signal CLK1 has a 50% duty cycle and clock 2 is one-third period delayed version of CLK1. The duty cycle at the output of the latch is in percentage is. So you have to find out the right answer. Go through the circuit carefully. The first option is 50%, then 30%, or 16.67%, or 10%. So go through the question carefully and try to find out the right option.
Ma'am, is there any formula to refer?
You try, then after that I will solve it. Okay. At least try.
Okay.
Just find out the T1. Okay. Then the output duty cycle is T1 by T clock. Then find out it in percentage. At first find out it on the T1. So you have to find out the T1. So what is given in this question? Uh, when the clock input is high and has zero propagation delay. In the figure, the clock signal CLK1 has 50% duty cycle and clock 2 is one-third period delayed version of the CLK. So you have to find out the T1. So T1 is equal to this 50%. So 50% of the duty cycle, half of the TCLK, minus one-third period delayed version of the CLK1. So what we are getting here, T1 is equal to TCLK by 6. Then output duty cycle is T1 by TCLK. Equal to 1 by 6. So it is in percentage, output duty cycle.
16.67, ma'am.
Yes, 16.67. Option C is the right answer. 1 by 6 into 100%. So please, for your exam, practice this type of question. 16.67 percentage. So the right answer is option C. So next move towards the question number 9. DRAM and SRAM are types of dash memory and solid state storage is type of dash memory. First option is the volatile, non-volatile. Second option is the non-volatile, volatile. Option C is the static and dynamic. And option D is the dynamic and static.
Ma'am, option A is correct, I think. Actually, DRAM and SRAM are actually volatile. Uh, so next, solid state storages are, I think, non-volatile, ma'am. Option A is correct, I think.
Yes, option A is the right option. Good.
Thank you, ma'am.
Okay. So next move toward the question number 10. An SRAM has address line of A0 and A15, A0 to A15 and data line width from D0 to D3. The total capacity of the SRAM will be first option just 16 KB, then 32 KB, or 64 KB, or 128 KB.
Ma'am, no idea, ma'am. Please teach me, ma'am.
I think one student is there. R is a key Amal. Can you solve the question? At least try, then I will solve.
I'm actually I just mentioned that address lines in 2 power. So 2 power 16 into how many data lines? So 2 power 16 into 4. Uh, so is it correct, ma'am?
Yes.
But the answer is, I got some. I got one answer, but it's not in the four options.
See, check it.
Ma'am, actually 2 power 16 plus 4. Sorry, 2 power 16 into 4.
So what you are getting, 32 kb or not? Just calculate this. But the formula how to find out is 2 to the power number of address line into number of data lines. Okay.
Yes, ma'am. 2 power 16. 2 power 16 value is 65k something into 4. So the value is something 2 lakh something, 2 lakh 62k, 62,000.
Just a minute.
Yes, ma'am.
Just a minute. Actually, the formula is right. So whatever is coming, this is the answer. Just try to calculate in kb. Okay. The right
Okay.
answer is 32 kb. You can cross check it, and the formula is right. This 2 to the power number of address line and into number of data lines.
Yes, ma'am. 2 power 16 is equal to 65 point something, ma'am. 65k something. So just into 4.
The answer is 2 to the power number of address line into number of data line. So number of address line is 16, right? Into 4.
Into
So
4.
whatever is coming, this is the answer. So next question, the sequential logic circuit differ from the combinational logic circuit because they depends only on the current input value. Option B is depends on both current and previous input values. Option C do not require the clock signal, and option D is are purely combinational systems.
Ma'am, option B is correct. It depends on both current and previous input values.
Yes, option B is the right option. Depends on both current and previous input values. So next move toward the question number 12. Which of the following represent a memory element in a sequential circuit? Logic gate, register, decoder, or multiplexer?
I'm registered.
Yes, register. This is the question number 13. Dynamic memory store information permanently in flip-flop pairs as charge on a capacitor or using a regenerative feedback.
Actually, capacitance.
Yes, option C is the right answer, as charge on a capacitor.
Capacitor. Yes.
Next question number 14. A latch is age triggered, label sensitive, clock independent, or asynchronous only.
Clock independent.
Is it clock independent?
Yes, ma'am. Latch does not have the clock. It depends only on the input. It does not have the clock.
Okay, clock cross check it between this label sensitive and the cross independent. Okay, just cross check it. Then the question number 15. In a bistable circuit, the stable points correspond to regions of negative gain. Option B is points where V in equal to V output on inverter transfer curves. Option C is zero feedback conditions, and option D is the crossover point of both inverter BTCs. So what is the right answer? In bistable circuit, the stable points correspond to. So what is the right answer? So the right answer is option B. Points where the V input equal to V output on inverter transfer curve. Next question is question number 16. A multiplexer based latch operates by sampling continuously, opening or closing feedback loops using clock. Option C is using the differential amplifiers, and option D is the cascading multiple NOR gates. A multiplexer based latch operates by
Using differential amplifier.
no.
No. Okay.
Please go through this type of MCQ and the numericals question. Okay, because in your exam also you're going to face this type of question. So please go through the lecture videos which are shared in the class. Okay. So the right answer is option B, opening or closing feedback loop using the clock. That's why I'm only here like taking this MCQ on the numericals which you are going to face in your exams, because already shared the theoretical part, and also one more TA is also taking the classes. So this is the question number 17. In a master slave latch configuration, both master and slave are active simultaneously. Option B is the master active when the clock is high and slave active when the clock is low. And option C is slave drive the master continuously. And option D is there is no clock dependency.
Option B.
Yes, option B is the right answer. Master active when the clock is high and slave active when the clock is low. Next question number 18. The
Ma'am,
main drawback.
ma'am,
Yes.
ma'am, the exams based on our assignments questions or the this problem solving
No,
session questions also, ma'am.
no, not only the not only the problem solving session, and not only the like the assignment question. I'm here, I have taken some like similar type of question which is in your assignment. So
Okay, ma'am.
some percentage type of question you can face in your exam. Okay, not properly all this question from the assignment or from the problem solving session, but
Yes,
some
ma'am.
percentage of the question you can face in your exam, this type of question.
Okay, ma'am. Actually, I'm going to face my exam.
Mhm.
Uh, Actually, I want to prepare these assignment questions and problem solving sessions. So, these two things I will prepare, ma'am. In other than which type of questions I want to prepare, ma'am. I will prepare these assignment questions. I will prepare the assignment.
Actually my suggestion is firstly go through the
Except,
lecture video, like in a
okay, ma'am.
particular topic you can solve some of the numericals or some of the like
Okay, ma'am.
MCQ type of question. And mostly the both tier taking the classes, so you can go through the problem solving. I think 30 to 40% question you can solve if you go through the question, the assignment and the problem solving question. But
Okay.
other than I think 50% or 60% question you can solve only when you are going through the thoroughly going through the lecture video and take the topics, and you will solve this type similar type of question.
Okay, ma'am. Okay, ma'am. Just 30% only.
No,
The
actually this is, I'm giving a small idea, not exactly 30%. Okay,
understood, ma'am. I understood.
actually
Actually,
what I'm trying to say, not exactly
yes,
30% or 40%, but some of the question you can face from the like similar, not the exactly same, but similar type of like they can take the same topic and give the another question. Okay, this type
yes.
of question you can face.
Actually, ma'am, I understood, ma'am. Actually, I'm studying this course for my PhD coursework. So that's why I asking this this type of questions, ma'am. No problem. Okay,
Okay.
ma'am.
Okay. So,
Okay, ma'am. Okay, ma'am.
okay.
Ma'am, actually,
So,
the exam is 25th or 26th, ma'am.
okay. Yes, I think this is the last session in this course.
No, ma'am. The exam is scheduled on 25th or 26th, ma'am.
No,
26th.
actually, this class I have to take the 12 or 13 week session. So, this is my last class. So, please go through the. I have uploaded all the lecture like videos and the like PPT in the sites also. I think you got the email regarding this, right? So both
Okay.
they
I,
uploaded the lecture video and the
yes, ma'am.
PPT.
Yes, ma'am. I received everything, ma'am. I just asking when is the exam? Actually, the date is scheduled 25th or 26th, ma'am. That's why.
Okay, the exam time you are asking about, actually it is not shared with us also. You will get by the email.
Okay, ma'am.
Okay.
When we'll receive our hall ticket, ma'am? Next week or?
Actually, I'm not sure about it.
So thank you, ma'am. Okay, ma'am.
Okay.
Okay, ma'am. Sorry for disturbing, ma'am. Yeah,
No,
continue.
no, it's it's okay. So this is the question number 18. The main drawback of the transmission gate-based latch is high delay due to inverter count. Option B is the large capacitive loading. Option C is the noisy output, and option D is the port uh, regenerations. So, what is the right answer? The right answer is option B, the large capacitive loading.
Yes, ma'am.
So question number 19, the clock skew refers to difference in arrival times of the clock edges at different points. And option B is the variation in logic delay. Option C, difference between the setup and hold time. And option D is negative edge clocking. So in my every session, I have taken the 10 question from the previous year, And then rather than the 10 question, like 35 to 40, 30, yes, 30 to 35 question each session I have discussed here. So only 10 question I have taken from the previous session, like this is 2025, so 2024 or 23, already this session already taken. So from there I have taken the first 10 question, and other than this 25 question I have gone through this lecture, and from there I have taken the question. So I think if you gone through all these 30, like per session 35 to 40 question, I think it will help you in your exam also.
Yes, ma'am. We prepared this 30 questions, ma'am. Just you are telling the ideas, okay, ma'am. So I just prepare the last 3 years assignment questions, ma'am.
Oh,
Ma'am, actually the answer is option A, ma'am.
yes, question number 19. The option is option A, difference in arrival time of clock edges at different point. So next question number 20 is low voltage static latches improve the performance by. Option A is using the high threshold devices. Option B is using the multiple threshold MOSFET. Option C is removing the slip transistor, and option D is the operating at non-volt at 0 volt.
I think option D, ma'am.
Yes, option B is the right answer, using the multiple threshold MOSFET. Then this is the question number 21. Given the T setup is 1 second, 1 nanosecond, TCQ is zero point 0.5 nanosecond, T logic is also 3 nanoseconds. So find the minimum clock period and maximum clock frequency. If this type of time is like given, in that time how to find out the minimum clock period, and from there how to find out the maximum clock frequency. So are you a student or you are teaching somewhere? Hello.
Yes, ma'am.
Are you a student or you're teaching, or you're working
I
somewhere?
am in teaching profession, ma'am. I am working as a assistant professor, ma'am.
Okay, okay,
I just 15 years crossed, ma'am. 15 years experience.
okay,
Uh, just I taking the VLSI subjects, MOSFETs, and digital circuits and each and everything, ma'am. But I am not familiar about this communication systems like this, ma'am. I just familiar about the digital microprocessors and VLSI designs papers, ma'am.
okay. So actually, I'm also a PhD scholar, and I'm
Yes, ma'am.
I'm
I saw your slides,
yeah,
ma'am. Yes, ma'am.
yes.
Yes, ma'am. Ma'am, you are a full-time scholar, ma'am.
Yes, actually, I'm in my final year of PhD, and
Oh, super, ma'am. Super, ma'am.
and regular students, and we are doing this PMRF session from our, like we are a PMRF scholar, so we have to do this type of session.
Okay, ma'am. Okay, ma'am. I best wishes, ma'am, to complete the PhD, ma'am. I am just a beginner,
Yeah,
ma'am.
thank you. Thank you.
I am just a beginner, ma'am. I just completed a course, just 1 year completed, ma'am.
Okay, so
Mm,
you are also in doing your PhD, right?
yes, ma'am. I am doing PhD in Annan Stream, ma'am. I am Tamil Nadu, ma'am. I am from Tamil Nadu.
So in which institute you are doing it?
Ma'am, I'm working in Seth Institute of Technology, ma'am. In
And your PhD going on which institute?
University going on Annan Chennai, ma'am.
Okay.
Part-time scholar, ma'am.
Okay, okay. Yeah, I understand it.
Yes, ma'am. Working in a private institute, ma'am, but doing PhD in.
But you have a lot of experience.
Yes, ma'am. Lot of experience, ma'am. But uh, a lot of experience in the theoretical topics, ma'am. But even this MCQ, I cannot recognize the questions with
But
the four
it's
options.
some actually it sometimes happen if you regularly like go through this topic and like solve. I think you can also prefer the gate syllabus. I think
Yes, ma'am. In this course, beginning of the time, it's very easy. Actually,
yes,
you are simply you are following the BJT. Yeah,
yes.
the
Then
BJT,
then it comes to
BJT
the
problems. Yes, ma'am. It's very easy. But after some days, MOSFET basics.
yes,
This MOSFET differential amplifier concepts and then the MOSFET to small signal conversion is somewhat difficult, ma'am.
yes.
Yes, this
That's a bit, bit.
yes, this is somewhat difficult, but we cannot teach this type of questions to the students. We are just teaching the BJT and what is the MOSFET regions and
The
what is the
basic, I
operation.
think, from the basic part.
Yes, ma'am. Yes, ma'am. These are the things we are teaches to students. Actually, they are students. Bachelor degree they are studying,
Hmm. I
but
think
in this,
yes, from the MTech, I think the like small signal analysis this starts.
yes, ma'am. Actually, the small signal conversion is somewhat difficult, ma'am. Even I'm a, master of technology in VLSI design also, but even in that studies also I cannot study this small signal conversions and the differential amplifiers. I did not study it, ma'am. Actually, I based on the low power design, the PMOS and NMOS conversions, and the PMOS NMOS power calculation, high speed, like this. Studied, and I done my PG projects also like this.
So now
But
you're like working on which in which field? Like I am
I'm
working
working
like
in.
the fabrication, like the sensor fabrication field. I'm working on like biosensor fabrications. Mainly, I'm like in my PhD, I'm totally based on the fabrication. My works like
Okay.
experimental work we are doing. We have fabricated the sensor, then
It's
we
very
connect with the
difficult.
biomolecules.
Yes, it is very difficult, ma'am.
No, I think it is
Yeah,
not
I'm
very
doing
difficult.
actually.
I have
Oh,
already taken in NPTEL the like the sensor actuator, the sensor fabrication technique, this type of, and my work is totally based on this. But side by side, I'm also from the background of the electronics and communication and this micro nano electronics, so that's why I'm also taking this.
I'm choosing solid state. I'm choosing this hemmed transistors is my research topic. So the future of, is fabrication like this. There, the more number of journals came like the
Oh,
fabrication.
actually, I'm asking about like I'm from the microelectronics, the some
Yes.
in the electrical engineering department. I'm from the microelectronics. So device fabrication is my field area. So in which field you are also working? I'm asking about it.
Yes, ma'am. My device is hemmed, ma'am. Hot mobility electrons, ma'am.
Okay.
Yes, ma'am. In that field, I am doing my coursework only, ma'am. I'm not familiar about that.
Okay.
I'm just
So
doing,
you
but
are
I.
doing your coursework. Then after that,
Yes,
you
ma'am.
will
I'm
start your
starting the
work.
survey work. I'm next to my survey work, and then only I will start at my work, ma'am. Now only I choose my device as hemmed, and I'm going to just to calculate the DC characteristics and each and everything, and using TCAD softwares, ma'am.
Okay.
Yes, ma'am. I'm not
Okay,
familiar about that, ma'am. Like you, I'm just.
okay, okay.
Ma'am, you are using micro devices, ma'am.
Yes, we are fabricating micro devices like the so. Like in my device, like you have heard about the silicon oxide, this type of
Yes, ma'am.
layer, and then the TMDC material that we have deposited, and you heard about the CVD and PVD technique, lithography. This type of technique we used, and we fabricate the sensor like it is in micrometer range, so you can think how much it is area. So then we fabricate the sensor, and then it like how it is work.
For which applications you are using this device,
And
ma'am?
actually my sensor is now based on the biosensor, like in the body serum presents the glucose and ascorbic acid, uric acid, resorcinol, this type of, like it can present in the saliva, sweat, or body fluid. So this type of molecules we can detect by the sensor, so I'm working on it.
Okay, ma'am. Okay, ma'am. I just it's good work, ma'am. But my work is not like this, ma'am. I just simulation only.
Okay,
Uh,
in my MTech also I have worked on the like FET, yes, FET based biosensor, but totally based on the simulation I have worked. But here I'm like experimentally we develop or we fabricate the sensor, and then we like take the molecules and we see the result.
yes, ma'am. Actually, I have a doubt, sir. Which means what's the difference between sensors and detectors, ma'am? So actually, we are having the number of photo
Hmm.
detectors to detect the light sources.
Like
So,
the
what,
if we're taking the definition of the sensor, but at first tell me what is the definition of the sensor. Like it's convert a physical signal to an electrical signal. Okay, like you if it is a like touch sensitive, let's mean the chemi resistive or something, you are giving some of the chemicals or molecules, then it changes its property, right? And how you are getting the signal, it is in electrical form, like in the physical, like you can see, you are walking in the road, some light is there, right?
yes,
you,
ma'am.
crossing through it, the light is it turn one. So how it is work, like you are, if you are going through the walk, like the path, then it's giving some signal. Okay, it is in the physical signal that you are present. Then what sensor done, it's convert this physical signals into the electrical signal, then it's detect now, then its output is the light is one. This is the definition of the sensor, like it's convert a physical signal to a electrical signal. Okay.
Okay, ma'am. Ma'am, actually, detector is just detecting only.
Detecting, like you can use the like biosensor, I can tell my biosensor is detecting ascorbic acid. It's mean it is selective toward the, like in my first work, my I have fabricated one sensor, and I like different there is in active area the different type of material I have grown, and it is detecting something. It's mean my device is selective towards this one particular molecule. Okay, I have taken like ascorbic acid, uric acid, or glucose, but among them one particular molecule my device can detect or selectively detect. Like in that case you can use the term like light detecting. It's when there are other things also, like the physical phenomena, like if there is a touch sensor, you are touching something and some like it is changing some property. Okay, so there is other physical phenomena also, but in that case only light is the physical things that convert the electric, the sensor converting this physical phenomena into the electrical signal. In that terms you can use it is detecting the light, because other than light is also something is present in the environment, but only detecting that particular things. But sensor is, it changes the physical signals into an electrical signal. The physical signals can be anything. In your case, if it is light photo detecting, then the physical thing is the light. If it touch sensor, like you're touching the sensor and it changes its property, like in electrical signal you can change, you can see the changes. So in that case, the touch is the like the physical things. Is it clear?
Yes, ma'am. Clear. Yes, ma'am. Actually, my research field is actually I am choosing the device as hemmed, and the materials is gallium nitride material I am using
Yes.
uh, to design the hemmed for the photodetector applications. So actually, photodetectors are many types: pin photodetectors, avalanche photodetector, Scotty photodetectors. So these are the photodetectors are there. So I just replacing the elements by the gallium nitrate hemmed. So I'm choosing.
Actually, in our lab also, we actually we purchase some hemp substrate like elegant hemp, aluminum gallium
Yes,
nitride. Okay.
aluminum gallium nitrate.
Yes.
Yes, yes.
So we directly purchase the hemp substrate. Then we deposited or decorate some of the material, and we like the then we fabricate the contact, and we can use it for the biosensing purpose or the ion sensing purpose, like water sensing. Okay. In there
Okay.
is in water is there is any like ion is present, we can detect it. So in our lab also we are work on the hemp based device, but we purchase it, not fabricate. Then after we like take as a substrate, then we deposit the material and all the electrode we have fabricated, then we use as a sensor, but not
Okay.
photo detector. For ion sensing purpose we used. And also I in my next order also I have discussed with my professor also, so maybe
Okay.
it can be used for the biosensing purpose also.
Okay, ma'am. Okay. I'm not in the field of biosensors, ma'am.
No,
I just.
actually it is just an application, and all the
Okay.
things are
Yes,
same.
yes,
Like
ma'am.
same way we are fabricating for the like photo detector, and for
Yes, ma'am.
someone is using for the biosensing, someone is using for the gas sensing purpose. But the
Yes, ma'am.
fabrication techniques are the similar. Whatever we are used, no, the same like CVD, PVD technique, like sputtering, thermal evaporation, this type of technique, like photolithography. These are all same things. We use the technique to fabricate our device.
Yes, ma'am. Actually, here the simulation only is possible.
Yes,
Actually,
yes,
fabric.
I can understand also. I have done my MTech from Triple IT Jabalpur. So in that case, in this that institute, only the simulation is possible. There is no fabrication facilities is present, because in that case, you need a clean room and also different type of machines you need.
Yes, ma'am.
So
Yes,
I
ma'am.
can understand the situation.
Yes, ma'am. Here in Tamil Nadu, we cannot fabricate. Is just
Because
we are.
I think only the fabrications are present in the like top IITs, and yes, only the top IITs I think it's have, and some of the labs like CSIR labs, this type of labs have this facility in
Yes, ma'am.
India.
But in IIT Madras is not possible. IIT Madras also they are not doing the fabrication process. They are telling to go for IIT Bombay or IIT Bangalore like that.
Okay.
Here just simulation only. Yes, ma'am. I'm
Okay.
actually okay, ma'am. I'm actually where you are from, ma'am.
I'm from West Bengal, Kolkata,
West Bengal, Kolkata. Okay, ma'am. Okay, ma'am. I'm
and
just in
now I'm pursuing
Tamil.
PhD from IIT Jodhpur, Rajasthan.
Yes, ma'am. Ma'am.
Yes.
Okay, ma'am. Just we are discussed about our researches, ma'am. Thank you, ma'am.
Sometime actually all the time we are doing the research and all these things, and this is the additional that weekly one day I have to take the classes.
Yes, ma'am. Is
For
nowadays
the
I am
research also we have to go through that type of topic or research paper which is related to our field, and this type of like this because from the first year to this going through the like I'm pursuing the fifth year now, starting of the fifth year. So all the time I am going through the fabrication, how to fabricate, how material I have to choose, how to detect, but it is little bit the additional things.
Yes, ma'am. The fabrication process is addition of the research work, ma'am. But it's a future work. It's a goal of our work, ma'am.
Yes.
Actually, it's not possible. I know that, but it's a future one. It's just I want to do like that. Actually, it's all one. Every one possibility we want to achieve, and that's all. But in the similar things, we are just trying to focusing the hemp materials. Actually, the hemp materials, in the simulation, we just reduce the power and just reduce the area and just we should increase. We want to increase the performance. That's all. And what are the characteristics we just learning. So these are the things only we learned from the simulation. So next we want to implement means we want to go for the fabrication.
Yeah.
Yes, ma'am. Ma'am,
Okay, so let's discuss this question. So, how to find out this minimum clock period? So, the if the T setup is given and then TCQ and T logic is given, so you have to add all these things. So, it is to calculate the TCLK minimum. So, it is 4.5 nanosecond. Then, how to find out the F maximum, the maximum clock frequency? So we know that f is equal to 1 by t. Okay, so f maximum is equal to 1 by tclk minimum. Okay, so 1 by 4.5 into 10 to the power minus 9. So it is just calculated you are getting the same type of things or not. 222.2 megahertz. Okay, so this is the question number 22. In the same way, you have to find out a sequential circuit has the following timing parameters. So these parameters are given. So find out the minimum clock frequency.
ma'am, the same formula can I use, ma'am?
Yes, you have to use the same formula. Like if the T logic is given, T setup is given, then TCQ is given. So in that thing, how to find out this addition all this time. This is the minimum clock time, and how to find out the maximum frequency from there. One by the T minimum. Okay, TCLK minimum. Minimum clock, sorry, not the clock frequency, the minimum clock time. Okay, and the maximum clock frequency. Max. If max, you have to find out. And I think in the PMRF session and the NPTEL session, this is my last class because I already completed my PMRF. So I have to, in this session, I have to take the additional only the 10 hour, but I choose that I will take the complete session. So I'm taking the additional classes. So I think this is my last class in this NPTEL session.
Actually, classes are very useful, ma'am.
Yes, because last 3 year I'm taking these classes. In 2022 ninth cycle, I got the PMRF. So here in the June, I think, yes, in June 2025 I have completed my PMRF. So after that I have to only just take the 10 more hour classes. But I have chosen that why only 10, I will
Actually,
take the
what is the use of this PM of a PM for PMRF classes for your profession, ma'am?
um, actually it is
Clinic
mandatory
regulation,
for all
clinic
the
relation.
PMRF student. It is mandatory that we have to yearly we have to complete the 50-hour classes, because
Okay.
for them I think this is a social services, like for the suicide, like other than the your research you have to do this 50 hour of yearly classes.
Okay, ma'am. Okay, ma'am.
And freely you have to like serve. You can take NPTEL classes, or you can teach in the polytechnic college or the school. So anywhere you can take the classes if you are a PMRF, but you have to complete this like the 50 hour. So I have to take only the 10-hour extra classes, but I choose that why only 10 hour, this class is like 24 or 26 hour, so I will took the whole classes.
Okay, ma'am.
So this is like after completion of the PMRF, like this is my last class.
Oh, this is your last class in PMRF, ma'am? Is
Yes,
everything completed?
from the PMRF side in NPTEL, this is my last class.
Oh, no, no, I'm asking this is in microelectronics, this is last class, ma'am, right?
No, not microelectronics.
Oh,
Like as a PMRF student, I'm taking in the NPTEL. I'm taking the last class.
okay, okay, ma'am, okay, ma'am. So
Because
next
this
week,
year, yes, this year I will also from 2026 maybe I'm going to complete my PhD. Also after that I will join somewhere, or that time if it is possible, then again maybe, uh, but
oh,
I'm not
coming 26.
I'm not also sure.
Oh, okay, ma'am, okay. Coming 26.
Yes,
Okay.
like 2026 I will complete my PhD.
Oh, sure. No, okay, no, okay. Coming 26, I think coming 26, your PhD Viva, ma'am. 20.
Yes, it's 2026 May. I think I'm going to give the open and all these things. Then I will complete my defense before, I think, um, like 2020, before 2027. I will complete all the process.
Oh, okay, ma'am, okay, ma'am. Ma'am, now we are publishing the papers, ma'am.
Yes,
Like
I have
quality journal.
already from the fabrication part. I have already published two paper, and third is like under preparation.
Ma'am, is Scopex or quality Q1, Q Annexa journals, ma'am?
Here, in one is IOP nanotechnology, and another one is IEEE sensor journal. You can go through my profile also, like by searching my name in IIT Jodhpur Scholar. You can get like in MTech simulation based work, also FET based biosensor. I have published some of the papers, and now I'm working in the fabrication lab. So from there also I have published some of the papers.
Okay, ma'am. Ma'am, I will contact you via mail, ma'am. If
Okay. And also, if you're like is some we want to discuss something about your research, like it is, if it is related to my field, also you can, or not only you, all the students can contact also by via mail.
okay, ma'am, okay, ma'am.
Like if there is a like possibility, like somewhere, like next maybe I'm going to work on the hemp or the bioaffinity waste sensor, so that type of like fabrication is possible or not, or how we are working, because it's
Actually,
little
the
bit
Hendrix,
interesting, because I have worked on the simulation, then I came for the fabrication lab. Yes, it is
okay,
like hectic, you're physically you're working, and it's took like one deposition of the CVD. I'm just sharing my experience because this is my last class also. In CVD we prepare one sample, it took like more than 8 hours, but we don't know it is prepared or not, like this way. So some in like atmospheric pressure CVD, it's took like more than 50 to 60 run. So one run it's need 8 to 9 hour. So you can think how much time it takes when you're optimizing one material parameter. Then you fabricate and you don't know it is like, yes, you have the idea that it may work, but you have to like all the optimization you have to do. Then we have to fabricate the device, and all these things you have to do by your own.
Okay, ma'am. Okay, ma'am. I'm
Yeah.
actually for biosensor applications. Which device is suitable, ma'am? HEMT or tunnel fit, ma'am?
Like here I'm working in simulation part. I have worked on the like NMOS, like reconfigurable based sensor. You can, if you go through my lab paper, you can see reconfigurable, like you are changing the like the like how you are giving the voltage or something. So by it the changing it, you the device is working as a reconfigurable, like in MOS, PMOS, NTFET and PTFET. And here in the fabrication part, when I come here, I have worked on the resistive, like we have now we have fabricated the device. Like when you are introducing the biomolecule into the device, it changes resistance like property. Okay, so it is little bit different type of work, not totally different, it is like of different type of work. Like here you have heard the resistive bios sorry, gas sensor. So chemi resistive, this word you can, this is suitable, like chemi resistive type of biosensor I have worked on. Like some biomolecules like glucose or something, you are interacting with the your sensor and it changes its property, like there is some active material is also present. So when it is coming contact to that particular molecule, it changes its property, like it changes its currents or in the voltage form or the resistance form. And from there you can like optimize the device, how it the device is like changing its property and how it's reacting with the molecules.
Ma'am, but uh, devices have the different properties, ma'am.
Yes, in my case the material properties changes. Like I have worked on the TMDC, transition metal, this type of TMDC 2D material. You have heard about the 2D material, the two dimensional material.
Yes, ma'am.
Yes, so this 2D material changes its property when it is interacting with that molecules.
Okay.
So in the term of FET or tunnel, next I think that I will work on the FET based device. But tunnel fit I have not worked on in fabrication based. I have not worked on the tunnel fit. So I'm thinking to work on the hemp device, and also some of our colleagues also work on the hemp based ion sensing. So I have little bit knowledge about it, how it's work, how they fabricated it.
Okay, ma'am. I'm actually which software you're using for simulate, ma'am?
For simulation in MTech, I have used the Silvaco TCAD.
Oh,
And
yeah.
what you are
Okay.
using?
Yes, ma'am. I am going to learn, ma'am.
Yeah, okay. So I have used the Silvaco TCAD, and here totally based on the experimental.
Yes, ma'am. Is TCAD is more Silvaco TCAD is a basic version, ma'am. Yeah, so advanced versions are more, ma'am.
Yeah,
Silvaco TCAD.
actually, in that case, in 2021, I have completed my MTech. In that case, in our institute, we have only the facility, so that's why I worked on it.
Okay, ma'am. Okay, ma'am. Here we don't have, ma'am. We just using bilateral versions.
Which one?
Learning now, ma'am. And yes, ma'am.
Which one you were using?
TCAD, ma'am. TCAD
Okay.
2018 version. Uh, I'm using, ma'am.
Okay, okay. Let start the session again. We have more. I think 12 question, 12 or 14 question more. So tell me what is the answer and how to solve it. So TCLK minimum is just addition of this three. So will get the 8.5, I think, 8.5 nanosecond. So F max 1 by 8.5 nanosecond it is. So you will get 117.6 megahertz. Okay, this is the question number 3. If a latch has three inverter delays of PD inverter equal to 2.5 nanosecond and one TG delay of zero point 0.1 nanosecond, find the TCQ. See how to find out this. TCQ is equal to the three inverter delays. So 3 into the how much delay? 0.2. 0.2 and 1 TG delay is zero point 0.1 nanosecond plus zero point 0.1. The answer it is zero point 0.7 nanosecond. Okay, so this is the question number 24. Clocking strategy primarily affects which parameter in sequential circuit? Functional correctness only, propagation delay of logic gates only, timing synchronization and maximum operating frequency, and option D is power consumption only.
Power consumption.
No, it is option C, timing synchronization and maximum operating frequency. Question
Okay.
number 25. In a synchronous design, all circuit elements operates without any global clock. Option B are triggered simultaneously by a global clock edge. Option C is the operate at a random times. Option D are clocked by different frequencies.
Option B, ma'am.
Option B are
B.
triggered simultaneously by a global clock edge. Question number 26. An asynchronous circuit is one in which clock is distributed globally. Option B is timing depends on the logic data flow, not global clock. Option C, phase or all clocks is same. Option D is jitter is minimized.
Option B.
Yes, option B. Timing depends on local data flow, not global clock.
Actually, that question in jitter is also minimized, ma'am. Actually,
No, here, yes, an asynchronous circuit is one in which timing depends on the logic data flow, not global clock. This is the right answer.
okay, ma'am.
This is the
Okay.
question number 27. TCQ is given, T logic given. I think this type of similar type of question you have solved. So we can
Yes.
solve this, right? Just addition these three, you will get the minimum frequency, minimum clock period, and how to find the maximum frequency, just 1 by TCLK minimum. Okay.
Okay.
Then question number 20 is, I think, yes, this, okay. Question number 28. The TCQ is given, T logic is given, setup is also given, and the delta is also given. And you have to find out the TCLK minimum. In that case also, you have to additional this 4. Okay. How to find out the minimum TCLK? Just addition this 4. And for the maximum frequency, one is the same equation you have to find out, the 1 by TCLK. Question number 29. Clock skew in a sequential circuit occurs primarily due to option A is the unequal interconnect length of a clock path, option B differences in threshold voltage only, option C is the variation in logic gate delay only, and option D is random switching of register.
Option C.
No, question number 29. The right answer is option A. You can cross check it. This type of question, okay? If you have any
Okay.
doubt, you can cross check it. The answer is question number A. Um, Unequal interconnect lane of clock path. Question number 30. A positive clock skew means the destination clock arrives earlier than the source clock. The destination clock arrives later than the source clock. Option C, both clocks arrive simultaneously, or option D, the data arrives before the clock.
Data arrives before the clock.
Question number 30, the answer is option B.
B. Okay.
The destination clock arrives later than the source clock. Okay.
Okay.
So option 31, sorry, question number 31, clock jitter refers to spatial delay mismatch, temporal variation of clock period, or change in supply voltage or buffer mismatch.
Option D.
Yes, temporal variation of a clock period. So this is the question number 32. So how to find out this? Tell me how to find out if the minimum clock period that these datas are given. So in that case, you have to just add all these things. Okay, just see
Yes.
how to solve it.
Yes, my previous slides we solved.
Yes. This is a question number 33. The main purpose of a peripheral circuit in a memory is option A to store the data, option B to amplify the signals only, option C to perform the read or write operations, and option D to provide the power to the memory core.
Read and write.
Yes, option C is the right answer to perform the read and write operations. Question number 34. A memory array has 1024 word. How many address line are needed? How to find out the address line? Tell me. Just log 2 base this one, this 1024. Wait, this 10. Just cross check the calculation. Okay. So how to find out the address line? This is the formula k equal to log 2 base the memory array, the number of word. Okay. So next question number 35. If a memory cell has a read access time of 10 nanosecond and write access time of 15 nanosecond, what is the maximum theoretical operating frequency assuming on read or write per cycle? So how to find out this? Just directly you have to write the T cycle is equal to 15 nanosecond. The write access you have to take. Okay. T cycle is equal to 15 nanosecond. Just see how to solve. Then a similar type of question you are will going to like practice. F max, how to find out the F max? Tell me. 1 by T, right? 1 by T cycle. So 15 into 10 to the power minus 9. So you will get, I think, 66.67 megahertz. 66.67 megahertz. One more question I have taken. So if the DRAM cell capacitor CS equal to 30 F farad and it is changed to VDD 1.8 volt, find the stored charge. So tell me how to calculate the stored charge if the capacitance value is given. So how to find out this? Just directly multiply the capacitance value with the VDD. Okay, this is the formula. The CS into VDD. The stored charge equal to CS into VDD. 30 into 10 to the power minus 50. 15 into 1.8. So just cross check the
Or something.
value. 54 into 10 to the power minus 15.
Before
So the charge is this. This is the answer. Okay, so this is the last question. I'm going to end the session here. Thank you for joining the session.
thank you, ma'am.
Okay. Okay, you can leave.
Okay, ma'am. Thank you, ma'am. Ma'am, if I have any doubts in my research, I will ask, ma'am.
Okay, okay.
Okay, ma'am. Ma'am, this is the last session, ma'am, and